Thanks for checking in, guys. It's been a while. It's not the winter anymore, so you don't hear from me as much. But we got some severe weather out in the nation's heartland, particularly tomorrow, and it's significant enough where I wanted to make a video on it real quick. Because I do think you're going to see a lot of reports of tornadoes. Unfortunately, you probably will see a lot of damage in certain areas out there, especially in Nebraska and parts of Oklahoma, where all the ingredients are there, and they're pretty impressive. Let me show you really the anatomy here of a severe weather outbreak. So basically right now, we have this big upper level low pressure center that's spinning over the west, okay? This is bringing with it very cold air aloft, okay? Ahead of this low pressure system, let's actually go to tomorrow because this is what we're focusing on. So ahead of this low pressure system, right over Nebraska, in particular Oklahoma, you have a lot of warm, moist air coming in off the Gulf of Mexico, okay? So warm, moist air, cold air aloft. When you talk about instability, when I say instability, how does a parcel of air rise up? The higher it can rise, it condenses, it turns into big storms. It's a function of the temperature of the air parcel and the environment around it. When you have a cold environment around it, you have surface heating, the air parcels heat up, they expand, they condense, and you get something called supercell thunderstorms if you get enough rotation. And when you have wind directions that are coming basically almost due south, okay, let's actually jump ahead to when this outbreak is going to be. So around, say, Tuesday evening, you literally look at this, guys. You have warm, moist air, okay, especially over Nebraska, coming out from the Gulf. You then, this is at, say, 5,000 feet in the atmosphere. At 18,000 feet, you have this upper level energy, okay, which is going to be coming across, okay, more from the east, or I would say, or more from the west or southwest. That causes spin. Now, many times these features might be present, and there's actually a little bit of a warm layer, elevated warm layer, say at about, I don't know, anywhere between, say, 5,000 all the way up to 15,000 feet. And that could actually prevent the air from rising any further. That's not going to be the case this time. So we're not going to have something called a big cap in place. So what's going to happen is storms are going to fire up. And you can see the NAM model, by the time we get to tomorrow, let's go here, tomorrow afternoon, it's really showing some significant supercells spinning up, and you can see these little isolated areas of blue. That's the model trying to show you supercell thunderstorms spinning up. And actually, this simulated radar here probably shows it a little bit better to the point I'm trying to make. You can see all these will be severe storms, especially over Nebraska and Oklahoma is what I'm really focusing on. The reason why is because if you look at some of the significant parameters for instability, what I'm showing you right here is called the Energy Helicity Index. It basically is a combination of the energy a parcel of air has, how much it can rise up in the atmosphere compared to the environment around it, and also something called shear. So what's the difference in wind direction with height? And you can see by the time we get to tomorrow here, there are some pretty extreme values. Values over a 5, which do indicate supercell storms and potentially very big tornadoes right over this area. So if you turn on the Weather Channel tomorrow, especially tomorrow evening through tomorrow night, you're going to see a lot of action out there, guys. Unfortunately, like I said, there's going to be disruption. We have a very unstable air mass. A lot of times, this is probably a good way to show it, what you end up having is, so when you have these areas of low pressure aloft, it actually, ahead of it, something called a dry line. So what you're seeing here is, these are dew point temperatures. Notice how the dew point's 70 here, and behind it it's 35. Well, the warmer the air, the more moisture it can hold. So you have all this warm air here, all this dry air behind it. Dry air is denser than moist air, believe it or not, so that helps a lot of lift. And supercell thunderstorms are known to form where that dry line is. So you're going to see, again, Nebraska, Oklahoma tomorrow. Watch out. You're going to see big storms develop on the dry line. And finally, when the cold front eventually comes through later on Tuesday, I'd say particular Wednesday, then you get more squall lines and stuff to develop. So I'll be on top of it. Just want to give you guys a little bit of a perspective on this severe outbreak tomorrow out west.